Now let's see an example of a physical problem we can solve using antiderivatives. Suppose an object travels with velocity function 25 minus 10t, and that its height at time 1 is 40. And we want to find the object's height function. So when you have an object that's moving just up and down and it has some height function h of t, we know that the derivative of h is equal to that velocity function. So we don't know what h is, but we know the derivative of h. So from this, it follows that h must be an antiderivative of that velocity function. Now the antiderivative of 25 is 25t. It's 25t instead of x here, just because t is the variable that we're dealing with. And then the antiderivative of 10t is 5t squared. But remember, we have this plus c here, and we actually need that in order to solve this problem. Because basically, I know kind of the general shape of my height function, but I don't know the specifics of it. And I'm going to use this extra piece of information in order to find that. So to say that its height is 40 at time 1 is to say that h of 1 is equal to 40. So okay, I want for 40 to be h of 1. On the other hand, this is h of t right here. And so if I plug 1 into that, I get 25 minus 5 plus c. Also then I get 40 is 20 plus c, so that means that in this case c has to be 20. And so my height function should be 25t minus 5t squared plus 20. And actually, let me go ahead and just check that, because a problem like this is easy enough to check. So I have to check two things. I want to check, first of all, is the height at 1 actually 40? Just to make sure that I understand what I did here. So I go and I plug 1 into my function. And yes, I do in fact get 40. The second is the derivative of h equal to the velocity function? Well, the derivative of 25t is 25, and the derivative of 5t squared is 10t, and finally the derivative of 20 is just 0. So yeah, it does in fact match the velocity function. Okay, so let me point out just some sort of key things here. First of all, when you're solving a problem like this, you have to write that plus c. Without the plus c, you're not able to get to the right h function that has this extra factor that makes this sort of extra piece of data work out. But second of all, the extra piece that I ended up adding to h is not the same thing as what the initial piece of data is. In other words, h of 1 was 40, but I added 20. A common mistake is that people will just take this number here and put that in as c. And while that is sometimes the right thing to do, it is not the right thing in general. The initial piece of data determines c, but it is not necessarily equal to c.